Hi, everyone. The presentation is about attacking vehicle fleet management systems, and this was done with a friend of mine, Ramiro. Unfortunately, he couldn't be here because of other obligations. So Ramiro Pereja Veredas is a principal security analyst at IOActive. He likes hacking anything that's on hardware. So fault injection, side channel analysis, reverse engineering, exploitation, all that's fair game to him. I'm Yashin. I'm a security consultant at Xebia. My specialization is also embedded systems. I like to reverse engineer and exploit whatever I can get my hands on. So my desk is usually littered with a lot of devices. So what do we know about the current automotive hacking scene? Not a day goes by without some news about car hacking, whether it's relay attacks, something like key fob based attacks, or even Teslas being hacked over the internet. All of this led us to believe that there is quite a few things going on, but we want to do something by ourselves. Boo, boo, boo. Slides are stuck. Give me a second. Oh, well, yeah. Yeah, so our impression is that researchers want to hack cars. And usually they don't go for the cheap ones, they go for the expensive ones. Which raised the question, are security researchers underpaid? Infotainments are the usual attack vector for these sorts of attacks. Immobilizers and key fobs are also common attack vectors, and they're gaining in popularity. For vendors, we assume that the main effort would be in securing these infotainment systems because, hey, if that's the main attack vector, why not focus on that? So we made a hypothesis that the security of many of the other automotive connected systems could have been neglected. So what does this mean when we look at the devices? Our research focused on automotive embedded devices, which are permanently connected to the internet. And we did not want to do infotainment systems for the reasons we mentioned. A lot of people have looked at it, and we weren't interested in it. We also wanted the ability and the potential to launch massive scalable attacks. What do we mean by massive scalable attacks? We want these to be remote attacks. We want this to be able to affect entire fleets. We don't want to do a lot of work because we are very lazy. So it needs to be zero or marginal effort or cost. It should have a big impact. So these were the things that we were looking for when we were looking at this sort of attacks. Who recognizes the movie? Fast and Furious, yes. So these are the things that we were looking for when we started. Yeah, now we do office presentations online on a Linux laptop. Doo-doo-doo. I apologize for this. Okay, we're back on track. So we started in 2020 as a side project. We do this in our spare time. We have more than 15 devices or systems tested, and that's fully black box. Almost every device that we tested had high impact vulnerabilities that could be exploited remotely. What we wanted to focus was on low hanging fruit, so things that we could easily exploit or that we could easily find. So for that reason, we did not do in-depth evaluations. Just enough to find the low-hanging fruit. And all the devices that we used were in some way associated with fleet management control or fleet management systems. One other thing we want to point out is none of the attacks that you see here is going to involve complex attacks. All of this is easily doable for anyone with limited security or even just scripting knowledge. We presented this in a few conferences before, uh, but not the full impact and the full disclosure that we're going to do today. So we presented some aspects of it at ESCAR Europe in 2022. And we had a presentation on the challenges we faced while trying to disclose these vulnerabilities at SOS 2023. So one of the things that we previously presented was the Movistar card dongle. So it's an OBD2 dongle that goes under the dashboard of your car, which allows you to have a Wi-Fi hotspot, a GPS tracker for anti-theft services, and also emergency call if needed. So many major mobile providers offer this similar product, and a lot of fleets or vehicle fleets are controlled by something similar. The vulnerabilities that we found were open debug ports, a buffer overflow in the web interface that allows runtime control of the device, and a spoofing vulnerability due to the broken crypto that's used for authentication. So this could allow impersonation of the server or the car. The vendor was very quick to respond, and they patched it within a few days. We also presented about a vulnerability in the 5G modem that's used in a few vehicles. So it's a Quectel RM500Q. The vulnerabilities we found included a command injection in the AT command parser that allows for runtime control, and an insecure auto communication that allows for MITM if you're in the same network. Remote exploitation would be possible for this, but it's not easily scalable. You need to be in the same network. Another set of researchers found this simultaneously, and they reported this. You can find details on the NNS blog for more details. We also presented a bit about MQTT exposed devices. So we found multiple message queue brokers online that allow that expose automotive devices. So what we found were EV vehicles, aftermarket telematics boxes, EV chargers, and some OBD2 dongles that are connected to this. One thing we'd like to stress is that the devices themselves are not what's vulnerable. This is due to insecure configuration by the users. So what happens is that some users get API tokens from their cars or from their apps, and then they host it on an MQTT broker that they expose to the internet. That's what's causing these to be vulnerable, so it's not the devices themselves. So what do we present today? Today, we are focusing on two telematics boxes used for fleet management. We choose them because they represent the worst case scenario in automotive security. So high number of affected vehicles, around 200,000, very high impact, that's the full control of the fleets, low to medium effort in finding the vulnerabilities, and very low effort in exploiting them after you have found it. And almost zero response from the vendors. Before we continue, what is a telematics box? A T-box or a TCU is an electronic controller designed to send data to the backend and also control the device to some extent. So it's used for vehicle to infrastructure, vehicle to vehicle communication. It's used for vehicle tracking. It's used for remote diagnostics, fleet control, and sometimes emergency call that automatically goes out if your vehicle crashes. Most of the modern vehicles have it. Sometimes it's added as an aftermarket addition. So the first device that we're going to talk about is the HopeChart HQT401. It's an Android-based telematics box with Wi-Fi, Bluetooth, and 4G. It's used for fleet control, and it has location, diagnosis, telemetry, and some form of remote control. We found references in the code that allows the sending and receiving of CAN packets. Where is this used? So it's factory installed by at least one major vehicle manufacturer, SANY. How many of you have heard of SANY before? I see a few hands. It's one of those companies that you don't really notice, but they're all around you. They're the third largest heavy equipment manufacturer in the world, and first in excavators since 2020. They make more than 100,000 units a year. So the telematics box was installed by default in SANY, especially in China. These are also installed as aftermarket, and so this is one of the pictures that we got from the website of the vendor of the telematics box. And the suggested implementation is to connect this telematics box into a heavy truck. So we bought one telematics box off Taobao, so it's like AliExpress in China. and we found a Quectel EC20 based PCB. We did some very basic PCB reverse engineering. We found a connector that appears to be USB, and then we measured with an oscilloscope, found the differential signal. So yeah, it's probably USB. So we connected a USB cable and connected the host side to a PC, and suddenly we noticed an ADB shell popping up, and we connected and we got root. After that, it was just a matter of running the command to dump the firmware this way. So we got access to the full rootfs. We looked at the binaries. They were not stripped or protected in any way. So we followed the usual reverse engineering process for embedded reverse engineering. So looking at the init scripts, the running process, config files, network connections, all the usual stuff you do for embedded reverse engineering. Two binaries caught our eye. So one was MQTT proxy, and the other one was a plugin that said MQTT Sani Crane. At this point, we weren't really sure if this referred to the same Sani, but we looked at the content, and it appeared to have some sort of communication with the backend server. So we found that the device connects to an MQTT server for sending telemetry data and for receiving commands. We got the connection info from the config files. There was no authentication, no encryption. And the thing with MQTT is that if there's no authentication and if it's not properly configured, which is the default state in most brokers, you can just connect to it and say, hey, give me all the data that you have, and it'll give it to you. So we got this nice screenshot from the server that says, hey, these are all the devices that are connected, and there's all the data that's being sent or received. And we could see all of the data for all the fleet vehicles that are connected to that server. Vehicles are identified by the ICC ID, which is kind of like the serial number. And we can send data impersonating any vehicle or the backend. So we can tell the vehicle, hey, this command came from the backend, and the vehicle had no way of verifying it. So what could we do? Data sent us binary messages. So it was not plain text ASCII. It was binary, so we had to reverse engineer that a bit. And this, we did it using Ghidra. And the following information is continuously reported. So GPS position, metrics like speed, RPM, gas tank levels, odometer data, etc. Some information is reported under certain events. So you have diagnostic errors, CAN traffic. This is only reported if it satisfies certain conditions. All of this information can be sniffed and spoofed by an attacker. So anything you see on the MQTT server, you could just spoof it. So we made a dashboard to show all of this information because we wanted a way to see where the devices were and what sort of data was being sent. And this is the dashboard that we saw. So you might notice that most of the, or all of the data points are inside China. And this dashboard that we built in a Jupyter notebook could drill down into an area, see the ICC ID, the odometer data, the tank data, the runtime of the telematics box, the current speed, and we could actually see a vehicle moving live in this dashboard. So what else can we do? We can also potentially inject CAN messages because the backend can send CAN packets and the T-box injects them into the CAN bus that it's connected to. It's used for advanced features like remote vehicle unlocking or diagnostics. And as mentioned earlier, an attacker can spoof these. Also, we saw the potential for runtime control because there are OTA commands or over-the-air update commands that are supported by the telematics box. And one of the features that the telematics box advertises on their website is the ability to flash firmware onto other ECUs in the CAN bus. So all of this is possible. And we didn't see any firmware verification within the code. It could exist on a bootloader level, but we didn't see it. For obvious reasons, we did not try these two attacks. We don't want to break or do something worse with a vehicle that's passing through a Chinese highway. So, how did disclosure go? Obviously, this is not the first time that we are going to disclose this. We tried to reach out to the vendor. So, we found these in Q2 2021. We spent about half a year to a year trying to contact them just by phone, by email, by reaching out to them through Chinese friends. We could not get in touch with them. We also contacted ASRG, the Automotive Security Research Group, and they also failed to connect with the vendor. Finally, an ASRG contact in China managed to talk with Sani and HopeChat. Sani confirms that 60,000 vehicles are affected, and we got a message about 2 years later saying that the vulnerabilities are patched according to the vendor. We applied for a CVE and a CVE was assigned. Unfortunately, just before we did the SOS presentation, we were running the dashboard and we found the vulnerability is not fixed. So this is still vulnerable, by the way. We tried to contact Sani or HopeChat using all channels possible, but yeah, it's still vulnerable. It appears they don't care, so the vulnerability probably will not be fixed until someone exploits them in the wild. Potential affected vendors. This is also a screenshot from their website. These are all the vendors that they say they work with. So probably there are other servers for all of these companies, and they might be affected as well. So that's about HopeChat and Sani, but you might sense something that's common across a lot of these attacks, which is a vulnerable backend communications. And I'd like to talk about MQTT in specific. So when we hacked this T-box via the MQTT server, it led to some interesting questions. Are there more misconfigured servers like this out there? And if there are, can we find them without knowing of their existence? And if so, could they be used for a massively scalable attack? So the general OSINT playbook, you start with shutdown or census searches, which is Google, but for devices. And census allows you to search for only MQTT servers that are open. And we narrowed it down to certain specific automotive terms. So we targeted things like other MQTT servers, Kafka servers, RabbitMQ servers, etc. And the question that we had was that, could we do what we just did, but in reverse? So earlier what we did was we got the hardware, we got that off Taobao, we extracted the firmware, we found the MQTT server, and then we created an exploit. Can you find the MQTT server, reverse engineer the protocol, and then create an exploit? So that was a question that we had in our mind. And this also has been done before, right? So there's a lot of prior research on the internet about hacking devices through open MQTT servers. This is not new information. This is not something that people have not done before. So unfortunately, we were spoiled for choice. This might be surprising, but there are a lot of unsecured things on the internet. So we found things that we weren't looking for. We found oil rigs, ship data, license plate readers, and more. Disclosure is still ongoing for all of them, but we did find some more interesting than others. And the general approach that we used was to connect using tooling such as MQTT Explorer. We created a dumping script that just dumps the data, and then we use some basic data analysis techniques to understand whether this data is useful for us or not. We usually tried running it overnight. In some cases, we tried running it at different parts of the day because we want to see how the data changes. And again, the question is, does the data change? Are there a lot of retained data that was put on the MQTT server a long time back and just left there? In the upcoming slides, you'll see a bit of redactions. There'll be quite a few things that are removed, and I'll explain why later and the importance of those redactions later. So we found one server that really stood out. So it was an unauthenticated MQTT server that seemed to contain a large amount of data. And we saw a lot of different diagnostic data. We saw engine performance, system information such as CPU, storage, RAM, and some sort of command request and response key. You have to keep in mind that at this point, we have no idea what this server does. We don't know who this belongs to. We just know that this is open and has interesting data. So let me introduce company F. F stands for security. And also, we'll explain what the company is later, but at that point, we didn't know. So we found this service, and this is a dump of the data with some redactions done. So you can see it's a bit of telemetry data that's being sent about whether it's online or not, what's the location, what sort of devices are connected, things like that. So we dug a bit deeper into this service, and everything seems to be under this Chiron topic. The Chiron topic had two subtopics, which were numeric values. And these numeric values appear to be the subtopics for which there were a lot of diagnostic information that were pushed to the server. So there were diagnostic information like the storage, the CPU usage, the IP addresses, but also some sort of command request and response scheme. The numeric value turned out to be ICC-ID. And again, for those of you who are watching closely, you might notice that there's, again, a recurring scheme within fleet management systems. While we were making sense of the data, we assumed that this was a fleet management system. And when we visualized it, we found a lot of devices. This is data that's after probably 15 to 30 minutes. These were individual vehicles that were connected to this backend. Then we had to find the owner, because you can't just say, hey, there is a random unsecured MQTT server on the internet. You need to know who this belongs to and who's responsible for it. So reverse DNS gave us some domain names, and we found another MQTT server containing this within the same domain space. Whois and other OSINT techniques gave us the owner, and yeah, they appear to provide a fleet management service. Our guess was right. They also provide devices to other services to track their vehicles, which meant that they had integration documentation online, which was very useful because we had a perfectly well-documented target now. Even though it was supposed to be black box, they put the documentation out there, so we could use it quite well. So we have location data, which means we know where the device is. But the question for every embedded hacker is, can you get root? So each topic, as I mentioned earlier, had a command request and response subtopic. Each command we saw had a token and an ID. What happens if we send a command to that subtopic? So there was this token, we just reused it for some commands, and it worked for some commands, and the others return an error. We don't know what's happening. You have to keep in mind we still don't have access to the firmware. We have never touched the hardware. We just know this exists somewhere. And each device costs around 600 euros. So we were wondering, maybe we should buy the device. Maybe we should just extract the firmware from there and then figure out how this works. But right before we did that, we looked at the data again, and we found a very helpful firmware update command with a URL that pointed towards where the firmware was stored. So we just downloaded the firmware and extracted it. Firmware was pretty easy to reverse engineer. No encryption, no complex file systems. Binwalk extracted it on the first try. So we grabbed the extracted file system to find the binary responsible for connecting to the backend MQTT service. So the Chiron watcher binary seems interesting. So we dug a bit deeper, and we realized there's no token required. It was just used for one command. So the only thing you need to do is just send a command to be executed with an ID, and yeah, just gets executed. There seems to be some credentials there that they want to implement for the future, but it's not implemented now. We looked at the files. We found some more interesting stuff. We had some easily cracked passwords in EDC Shadow. Users have pseudo writes for some commands. Private keys for SSH to a backend server, ECU or engine control unit configuration data, and some interesting video capture information. So then the question again is repeated, can you get root? So what we did was we took one of the ID values and incremented it by 100, and then we just sent that to the backend to see if you could get code execution. Turns out the ID value is just the epoch, the Linux epoch, in microseconds. So we just scripted it so that you would take the current epoch and then send it to the backend. So, and then we just executed the command and we got code execution on the device. Let's see if the demo gods are kind and if we can execute that right now. So this is live, and I'm just connecting to the service. So if everything goes well, we should be able to see, yeah. So those are individual devices that are connected that are currently popping up. And we have quite a few now, so I'm going to stop. I already pre-selected an ICC ID before, And if everything goes well, if that device is still online, let me just zoom in. If everything goes well, that should return a response. Yeah. So this response is coming from the device that's in the field. That's code execution on one of those telematics boxes right now. So still vulnerable. And yeah, as I mentioned earlier, this is code execution as a certain user. But we have code execution, but we don't have root yet. But we looked at the sudoers file, and we noticed that this particular user has some sudo privileges, and it can execute certain scripts as sudo. So how do we escalate our privileges? We looked at the different scripts that are part of the system, and we noticed that one of the scripts that can be called with sudo has some very nice command injection vulnerabilities in them, which means that we can just execute this particular file as sudo and then use a command injection vulnerability to get root. We did not test this because at this point we're already like, okay, we're executing code, we should just inform them and stop. We can also get live video, and this is a picture that we got from one of the devices, blurred for privacy reasons. This is all part of the features that are offered by the service. So we got this from the same server. What other things do we have access to? So the system also supports tire pressure management system. This might sound like something that's not that important because it's just tire pressure. But tire pressure has safety reasons for existing. There's a reason that major systems major automotive systems take tire pressure into consideration when braking, because that does play a role into how quickly you can stop. But more importantly, you have access to engine immobilization if that's enabled. So this device is made in such a way that it connects to the immobilization or to the engine lines directly, and you can safely immobilize the engine through the same service. You also have access to the CAN bus, because that's also one of the features. So you can send CAN bus messages, you can request things from the CAN bus. You can also send audio messages to the driver by using a text-to-speech service that's embedded in the system. There's a Bluetooth speaker on both these vehicles, and you can use the TTS service to essentially send whatever audio that you want. Obviously, these are critical findings, right? So developers need to know immediately. No way they wouldn't patch this as soon as possible, right? It's still unpatched. As of yesterday, and as you saw, right now, it's still unpatched. So it's not that we let them know for once and then decided, hey, we're going public. We created a ticket in their support system. And about 3 months ago, they sent us a message, the only response we got, saying that, yeah, this ticket has been discarded. So, and they said something like, we hope that we have helped you to the best of your satisfaction. I don't think that's true. We also involved CertCC, that is the part of CISA, and CISA is part of Department of Homeland Security in the US because it's a US company, and they also tried to contact them, but essentially CertCC gave us the go-ahead to go public, and they asked us to just get a CVE because they tried to contact them and they didn't get a response either. So this is the timeline. Initially, we reached out in April, and the only response we got from them was to push this into the support system, and we did. And we kept asking for updates. We did not receive anything. And in August, they discarded our ticket. In June, we involved ASRG again, the nonprofit. And in September, we involved CertCC and CISA. And finally, we put a final request via the support channel. And we made a phone call to the vendor HQ to ask them, hey, are you aware of this? Are you looking at this ticket? They said they would take a look at the ticket, but we still don't have a response. We finally got a CVE assigned on November 21st, so that's the CVE. And yeah, it's still vulnerable. This is the first time we're disclosing the name publicly. The company is Digital Communication Technologies, and the product is Cyrus. The website claims 120,000 devices connected to the system, and all of this could be vulnerable. At the most that we saw within the one server that we saw, it was around 4,000 devices, but there could be more servers out there. So, summing up, for HopeShot, we had around 60,000 vehicles affected by SANI's estimation, probably more vendors affected. And attackers can get telemetry data, they can impersonate vehicles, and read and inject CAN traffic. The requirement is that you have to buy this one telematics box of Taobao, reverse engineer it, find the server, and connect to it. From Digital Comtech, around 120,000 devices are affected based on the vendor's website. Attackers can get telemetry data, they can read and inject CAN traffic, they can get runtime control of the ECU, and have live video streams. There are no requirements for this. Anyone can find this on the internet without accessing the telematics box. And that's scary. So before we conclude, we'd like to thank ASRG for helping us with disclosure and also for granting us a CVE as they are a CNA. ASRG China also helped quite a lot with disclosure for SANI. We'd like to thank CISA for giving us guidance on how to disclose and what to do. And thank you, all of you, for having me on here. And it's a wonderful conference.
Thank you so much for this. This was absolutely fascinating, scary at the same time. Just like, I feel like that's a common theme for DefCamp. So let's take 2 or 3 questions. Remember, you get DefCamp hats for your questions. Let's start here and work our way through the other question askers.
Thank you very much for the great presentation. I really enjoyed it, and especially thank you once more for trying to keep your disclosures as responsible as possible. Although it's very hard, we have seen that. My question is especially, you have mentioned at the beginning of your presentation that some of the products are already implemented by the OEM and some of them are the aftermarket, right?
Yeah.
So if you know that OEM will be implementing or will be putting that a certain item into the architecture, they might have certain opportunities to maybe put them behind a certain gateway or whatever. But especially when we are talking about the aftermarket, they have at least very, very limited chance. What do you think on that point, and what will be your proposal to the OEMs or all the colleagues who are here and working from the design perspective and trying to protect their products for the aftermarket?
That's a good question. Thank you. So as an aftermarket edition, when we did this presentation at hardware.io, we were approached by one of the integrators who said that this is a very common issue in the entire automotive space. So this person was specifically working on telematics boxes being integrated into different automotive systems. And what he said was that this is quite common. And when he looks at devices that come across his desk, he actually finds this quite often. So based on what I have seen in the industry, there are people who already do security reviews before this is integrated, especially in the European market. And I would suggest the same for other vendors. So if you are using a third-party OEM, have an independent penetration test or even an internal penetration test being done on those systems, and then figure out if there are easily exploitable vulnerabilities. Of course, there could also be something that you can't catch, and that's why you need something like an incident response team or at least a security point of contact for your website. Thanks.
Okay, let's go to the back middle here. We're going to try to mix it up. We won't have time for all the questions, but you can find Yashin in the rest of the conference as well. And if you could please stand up when you ask your questions so the speaker can see you.
Thank you for your presentation. I wanted to ask you if you had problems with law, considering that you are trying to reverse engineering and look at the source code. And a second question related to this. Have you ever thought to build a department to, for example, let's suppose I have a car with this vulnerability and the vendor doesn't want to patch it. Do you have any idea how can I patch it on a custom department? Thank you.
Thanks. So yeah, legality-wise, that's why we try to not be too intrusive. So once we run a command, the commands that we ran, for example, are supposed to not do anything to the system. So it's PWD, who am I, and things like that. So we tried to be as least intrusive as we could, and we involved the legal entities in every country that we are talking to. So for SANI, we were indirectly in contact with the Chinese Automotive Vulnerability Disclosure Department and the Ministry of Information there. So we try to go through legal channels every time that we can. And for the second one, we went through CISA. and we try to report it through their ICS vulnerability reporting system so that, the government is also aware. The second part of the question regarding, how can vendors choose to how can vendors patch it if it's in a third-party OEM? That would be quite difficult. You can have some sort of add-on security by putting that in a separate network, or in case of CAN, making sure it's only connected to a very non-security sensitive CAN bus. But in most cases, if there are vulnerabilities and you can't really patch them, it's very difficult to put security on top of it. As the usual statement goes, security should be inbuilt, not add-on. So in this case, it would be quite difficult, I would say.
Okay, one last question. Let's go there in the middle, and then we'll wrap up.
Hi, thank you for the presentation. I was wondering if you had any results of this kind of servers used in the European Union in this area, and also if are there supposed to be any legislation to force, companies to secure this kind of security? It seems kind of logical,
Yeah.
Yeah.
Yeah, thanks. That's a good question. There are legislation that's ongoing. So I believe the UN R11155 is supposed to mandate security. There's also a lot of generic security laws coming up in the European Union that try to push towards, hey, this device should be secure by default. But as far as I know, within the EU, there are no fines mandated for specific cases like this. So that's one part of the question. There are upcoming legislations. The other one was regarding findings in the European Union, right? We do have some findings in the European Union that was not discussed here. We are trying to disclose it, and I'm on my second email to them with no response yet. So yeah, unfortunately, also in the European Union. So maybe another presentation in a year or so.
Yeah, I was just thinking about that. So next year we're gonna get to find out all about that, and hopefully we're gonna get to find out that the vendor actually did something about it.
I hope so.